Okay, we're going to start a new unit on angles. In this first lesson, UA1, is just on different types of angles and kind of more specifically pairs of angles. Like in this case, there's two angles that form a pair. Here's two angles that form a pair. And so it's a lot of terminology again. And so we'll start with the most basic angle. Kind of like in the last chapter, we started with the most basic postulate, the most basic idea that a straight line goes through any 2 points. Okay, with an angle. One of the most basic ideas is that a straight line makes 180 degrees. Okay, and we're going to use that fact over and over again. So a straight angle is an angle of 180 degrees. And we've mentioned that before. Okay, so we can apply that right off the bat to vertical angles. And two angles are vertical angles if their sides form two pairs of opposite rays. I'm not really a huge fan of that definition, but it's precise. In other words, there are two opposite angles formed by intersecting lines. Okay, so here we have intersecting lines. These are opposite angles. They share a vertex, which is why they call them vertical angles. But A and B are the vertical angles. An interesting part is that vertical angles are always congruent. Okay, and I can give you a quick proof why. Okay, and we're going to be doing these proofs later on where you have to prove to me some kind of a relationship. In this case, I'm going to prove to you that A and B are the same measure. And I'm going to do that by introducing or labeling this other angle C and then using our straight angle definition. And so we can say that we know that for a fact A plus C makes 180 degrees. And we also know, because it's a straight line, and we also know that B plus C makes 180 degrees. Both of these expressions are equal to 180, B plus C and A plus C. Therefore, they're both equal to each other. If they're both equal to 180, well, now we can just do a little bit of algebra and say, all right, we can subtract C from both sides. And when we do that, we're left with this true statement that A is equal to B. Okay, so that's kind of a real quick proof how we know that those two measures are the same. Okay, so then we can apply that and say, all right, solve for X. Well, these two angles are vertical. They're opposite each other. And so we know that, for a fact, X plus 16 is equal to 4X minus 5. All right, we take X away from both sides. And 16 is equal to 3x minus 5. We'll add 5 to both sides. Now 21 is equal to 3x. And I'm running out of space, so I'm just going to say we'll divide both sides by 3. And x is our final answer. So 7 is the value of x that'll make those two angles equal. Okay, so here's another kind of big idea based on that whole straight angle. Is that if that straight angle is broken up into many parts, all those parts add to 180. So consecutive adjacent angles on a line sum to 180 degrees. Okay, so the idea is on this one, we can say that B plus these remaining three angles, 45 plus 39 plus 24, all those parts add up to our whole that we know is 180. Find the sum of all those. B plus 108 is 180. Take 108 from both sides. We can find that that last remaining angle, B, is 72 degrees. All right, so we can do this one together. You'll do this one on your own. But the idea is, and you're going to see this a lot, this is a straight angle. Right here we have 90, and it says find the measure of DCE. So I'll just put an X there. And we know that this one's 90. Okay, so the sum of all the parts is equal to the whole. So that means 72 plus 90 plus X is equal to 180. Okay, again, we'll just combine our like terms. X plus 162 is equal to 180. Take 162 from both sides. and x is 18 degrees. And actually, it says find the measure of angle DCE. We just substituted x in for that, so we should finish our answer and say that the measure of angle DCE is 18 degrees. All right, go ahead and solve this one, and then we'll move on to page 4. Okay, another big idea. So we have the straight angles 180, all the parts on a straight line make 180, and now all the parts around a single point add up to 360. Okay, so if you have, basically it's two straight lines. You have 180 on one side, 180 on the other side. All the points, or all the angles around one point form 360 degrees. In these two examples, unfortunately, I didn't really choose the best two examples because we don't really need to use this property to solve. We could, but it would be more work than we need to do. So in this case, it says find the value of x and y. And we know that this is a straight line, AB, or in this case a segment, and CD is a straight segment. So these parts add up to 180. Okay, and we're just going to write down what we know to be true. Okay, we know that the sum of these two is 180. Y plus x plus y minus x is equal to 180. Okay, and we can simplify that. Well, x minus x is going to cancel. Y plus y is 2y. Okay, so, well, that's not true. Y is not 90 degrees. Y is just 90. All right, so now we know that y is 90. We can write another true statement. And we have kind of two possibilities. We could say 2x is equal to y minus x because they're vertical. Or we could say 2x plus y minus x equals 180 because they form a straight line. Well, let's just do the vertical one. We know that 2x is equal to y minus x. Well, we're also going to substitute, or we also know what y is, so we can substitute 90 in for y. 2x equals 90 minus x. Okay, so add x. So now we know that 3x is equal to 90. And x is equal to 30. Okay, notice we had to just, to find x and y, we had to do two separate equations. One to find y, one to find x. And it's not initially clear maybe which equation you need to write. So just write anything you know to be true. So in this case, you're going to find the value of x and y. Okay, the direction should say find the value of x and y. But write a true statement and see if you can find x or y. Okay, next, we're just going to talk about different types of angles. And really, I should have called this angle pairs or types of angle pairs because each one of these is complementary defines a pair of angles, so does supplementary. Okay, so we have complementary, supplementary, adjacent, a linear pair, and vertical. Okay, so in this first case, we have complementary. Two or more angles are complementary if the sum of their measures is 90 degrees. Okay, complements mean, well, together they make a whole. So in this case, our whole that we're talking about is a 90-degree angle. Okay, and then we have that angle separated into two parts. Let's say angle 1 and angle 2, and together those two angles add up to 90, so they're complementary angles. 2 is the complement of 1, and 1 is the complement of 2. Okay, so here we have a pair of angles, and you can see this one's 35 degrees, this one's 55 degrees, and up top it's showing you the sum. So the sum of these two is always 90, which makes these two angles complementary. Okay, if we continue, two or more angles are supplementary if their sum is 180. Now these angles don't need to be joined together. They don't need to be adjacent. So you could have, let's say, angle 1 that looks something like this, and angle 2 that looks something like that. And if we were to join them together, or maybe find their sum would be 180 degrees. But they can be touching, or they cannot. Doesn't matter. That just the two measures have to add up to 180. All right, so here we've got two angles. One is 123 degrees, one is 57 degrees. And notice together they make 180 degrees, so these two are supplementary. Anytime two angles form 180 degrees or can sum up to 180, they're supplementary angles. Adjacent angles, these are angles we've already discussed before when naming angles. These are two angles that share a common vertex and a side. Okay, so I don't have a lot of space, but I'll draw an example here. So here's an angle. And angle 1 and angle 2 are next to each other, and they share this common vertex. And they don't have any common interior points. Okay, and just so you know what that means is potentially you could have something that looks like this. Now, I probably should do this in different colors. But let's say there's a green angle. Well, I could have left it red, and there's a blue angle. They share a common vertex, but there's overlapping area in here, so they're not adjacent. As opposed to this, they share a common vertex, but there's no overlapping area. So here we see two angles, BCA and DAC, and those two just share vertex A, and so together they're adjacent angles, and that's all there is to it. Just two angles right next to each other. Okay, next we've got a linear pair. Linear means line. And so all we're looking at is a pair of angles that actually form a straight line, which means they add up to 180 degrees, which means they are supplementary. The difference is supplementary, they don't have to form a line. Linear pair means they do form a line. But all linear pairs are supplementary. Okay, so here we have two angles on a straight line, or two angles that form a straight line. That means their sum is 180 degrees. So because they form a straight line, they're a linear pair. And also because the two angles add up to 180, that means these two angles are supplementary. So every linear pair is always supplementary. Okay, and the last one I threw in here because it's one of the types of pairs, but we've already discussed it, and that's vertical angles. And vertical angles are just formed by the intersection of two lines. Okay, and that big idea with vertical angles is they're always congruent. All right, so this last pair of angles, you're going to see a lot over the course of this year. And those are vertical angles, angles that are opposite each other on intersecting lines. Okay, and the vertical angles are always congruent. Okay, and lastly, we'll just do a few practice problems. So you're going to have to be able to kind of read these diagrams, kind of extract the information that you need based on the definitions that we know. We have a 90-degree angle on a straight line, right? So that means the whole thing is 180. This part is 90. That means the remaining part is also 90. So 11x minus 2 and 5x minus 4 are complementary. Together they make 90 degrees. So we can write that. 5x minus 4 plus 11x minus 2 is equal to 90 degrees. And you don't have a lot of room here, so I'm just going to kind of skip the showing the work part, but we'll have 16x minus 6 is equal to 90 after we combine like terms. Add 6 to both sides, we get 16x equals 96. Divide both sides by 16, and you get x is 6. All right, so for this next example, we've got a linear pair, right? CBD and CBA form a straight line. Okay, so they're a linear pair. That means they're also supplementary. So we can say that 8x plus 9 plus 6x plus 17 together form 180 degrees. Okay, so we have 14x plus 26 is 180. Take the 26 from both sides, and you have 14x equals 154. So x is 11. All right, so this last example, all we're going to do is just name the pair of angles that we see. So whether it's adjacent, vertical, a linear pair, or just none. Well, 1 and 2, right, based on the information that we have, all we know is that 1 and 2 are next to each other. We don't know that they form a straight line or 90 degrees. So all we can say about 1 and 2 is that they're adjacent. And again, adjacent just means next to each other. 4 and 5, you can see they make a straight line, and they're also right next to each other. They share this common vertex. So they're adjacent and a linear pair. Okay, 7 and 9, it's the same thing. They're next to each other, and together they form a straight line, so they're also adjacent in a linear pair. Okay, 6 and 9. 6 and 9 are across from each other, right? They're opposite of this vertex. So they share a vertex. They're formed by intersecting lines. So that means they're vertical. Okay, and then lastly, we've got 2 and 6. Well, again, are they next to each other? No, they don't share a common vertex. They're not formed by intersecting lines. They don't make a straight line. So those two angles have no relationship there. Nothing. Okay, so that's it. Just angle pairs. There's 5 angle pairs. And then with that, there's kind of 3 big ideas. Angles around a point form 360. All the angles on a straight line add up to 180. And vertical angles are always congruent. And all that is based on the idea that a straight line is 180 degrees. All right, thanks for watching.